Okay. Now, in the special function register, these are the register with certain functions like power control, program status word, then serial port control and serial port data buffer. So these are the latches associated with the different ports, input output port latch, and this is also controlling the signals which are coming towards the CPU or they are gone out of the CPU. In addition to that, you have a serial port control. So you can connect your device like keyboard, mouse through the serial port and serial port data buffer. So what it will do is that whatever data is being sent from the serial port, that will go first to the data buffer or it is coming in. Some smart programmer, when they are having lack of extra memory, they can make a smart use of these fellows like data buffer and port latch to store temporary data for certain calculations. Okay, so you have to just think the methodology by which you can just temporary use, because there is just one problem with the stack pointer I have not discussed. You have to limit up to what level the stack can increment itself, right? If the programmer doesn't limit the stack, then it will continuously grow into the user memory part or RAM. And what will happen? It will destroy the permanent data or the data which is being used on a later stage by the CPU, right? So programmer has to make sure that I want to use this much part of the RAM as stack pointer. Otherwise, it can give you a big trouble with for the uh, this thing. So uh, these are the some of the limitations where you have to just keep eye, right? And you have to remember that, see, I can use the stack pointer, but if I don't set up the limit, it is going to overflow. And uh, it,
Sir, I have a doubt actually.
yeah,
So for 8051 for the serial port, is there any a fixed byte rate for transmission or
that
serial
we will see.
communication?
Yeah, that we will see in the baud rate concept, timer concept, right?
Okay, sir.
Yeah, because it is the right question that we have a serial port. Now, in my first lecture, I told you that whenever we have a computers, the actual speed is decided by the motherboard speed, the bus speed, not by the processor, the processing power of the processor. If the processor has got all the data on its head, means close to itself, then it can perform. See, 2 gigahertz speed is there and only 3 MB cache is available. So 3 MB and gigahertz. So you can just compare that gigahertz or gigabits, you can say, and 3 megabits, 10 raised to 9 and 10 raised to 6. That difference is there. So in 1 second, processor can process uh, 10 raised to 9 bits, but the memory available for the processor is only 10 raised to 6. So it has a limitation in processing, that whatever is available, I will process and I will sit idle, right? So many times you people will also feel that I have already read all this content, why I'm going repeating all these things. So this is the case. Some students are not aware of all these things because they have not got that books or they have not got any resources. And some students are out of their curious mind, they keep on reading all these things, right? So this is the condition. So their processor is working faster. Similarly, when you want to transfer the data, this timer is going to decide. There are four speed with which you can transfer the data, right? And that is called as baud rate also. So these are the some of the concept where they are used in this digital transmission also. So data transfer rate is there, where you can send certain bits per second. Then comes the combination of the bits, means total number of bits, and then the signal is divided into small parts or small voltage levels. So you will require analog to digital converter, digital to analog converter. With the help of these fellows, you are going to send the signal at a time, right? Means when you have a baud rate, in normal case, what you people will be doing is that you will set for individual clock, you will set 0 1 0 1, okay, this kind of thing. So clock pulse is going to send the data like this, whatever. But when you have a digital to analog converter and I to D converter associated with it, um, using some IC you are going to study. So this voltage level, say 0 0 0 0, if you imply 4 bits, 1 1 1 1. So in between, so it is like 0 to F, barabar. So in between that 0 to 9 and then ABCD to F, this can be sent. So you can set up the level that this is when all this is high. Okay. So now you will be sending 1 1 1 1, all one or F in one go, or in between there 0 1 0 0, right? So it is represented by some voltage level, 7 volt or 0.7 volt. This can be 15 volt level. This can be 7 volt level. This is 0 volt level. So these different voltage levels are representing the baud rate. So in one clock pulse, if you send only 0.7 volt, actually you are sending 4 bits, right? So you have compressed the data as a one number, so one voltage level, and then you send it entire that data very fast, because if 0.7 volt pulse goes outside, then the device will capture that, and then it has to chop this number, what is 7, for that analog to digital converter, which is matching with this voltage level. It will understand actually this fellow, instead of sending 7, it has sent me 0 1 0 0 signal, or 0 sorry, not this is not 7 volt, this is 4 only. So if you it sends 4 volt, this is 0 1 0 0. Okay. So this is going to send. So these are the smart tricks which are used to send and receive the data through this serial port or serial control. Uh, Here you will be sending some sort of digital 0101 binary number, right? So it may have this latch may have 8 inputs or 8 outputs bidirectional, and you have to enable disable them. In serial case, the serial digital signal will come, that will go into D2A converter. It will convert the signal into analog, and then it will go out. Okay. So, so these details will come into the next topic. But this is kind of a we can say the mind which is calculating that I come to know all these things, but uh, if there is a serial port, how it is going to transfer the data. So in practice, I am sending only one signal per second. But the result of it is that it is actually carrying four values or four digital things in it, or 1 byte information, right? So this is section like that. Okay. And you will have to carefully understand that how I can. So I was telling you that when we send our satellite in outer space or some space expedition, the signal they send is digital, which is compressed on some electromagnetic pulse. Now, if it is digital in the sense on time scale or on the space scale, complete, then it will take lots of signal to send it, because if 700 MB data you want to send it, 700 into 10 raised to 6 into 8 bits. If we MB means megabytes, then so instead of that we can compress to small level where only one pulse is having some two three datas. So automatically when the data will be received and stored, starting string to the end string, so there is some hash information also. And by comparing that, if the starting and ending data are stored properly and then they are decoded, you will get lots of information, right? And nowadays the processors are very fast, so they can compress the data, they can decompress the data, and this way the communication can become very fast. So that's why we have to understand this idea. Learning all these things, you can get it from YouTube, you can get it from the books itself, right? But em- employing this knowledge for the usefulness in our day-to-day life is most important. And the moment you start getting all this idea, maybe it can be reflected in the form of project or some devices which are working on these ideas, automatically people will come to you. And this is what we have observed with our past project student, that the moment she wrote one APK file app to record and send small video packages, she got opportunity in the industry where they found out that this fellow has got a very good application hand also, along with the basic knowledge which she gained in MSc. How to use this knowledge? This is what the need of industry, right? So most of the you will not get opportunity to become researcher or this thing, or even though you have opportunity, you will be facing lots of competition. But apart from that, in this world, those private industries which are catering all these different technologies, so where your application capability will decide your future. And nowadays we are hearing lots of things like WhatsApp app is now releasing all the private information and all these things. So we have already sold our private information to them by an agreement while installing the app, like Facebook or Google, everything. All the social media initially they give you, which you don't read, but you accept by clicking button. They say whatever you upload, this is their property. Even on the Wikipedia also, whatever you upload or on YouTube, that becomes their property, so they can anyway use it or misuse it. If you don't want to upload it, then you should restrict it to your own domain. That is the main thing. Anyways, let us see on these things. The stack pointer has got this is a special function register. So the all these registers, if you see up to 8D, stack pointer 81 T mode, which changes the timer or counter mode. Timer control means uh, one is used to decide the mode, whether it is going to use it as a timer mode or it is going to count, means it is going to work according to the external clock pulse or any event. And second is the button where you start and stop, so T control is there. Then there is a timer low byte, timer high byte, and TL1 and TH1. So these are the register associated with this. And from 0 is 0, or actually you can say 000 to 8D, everything is mapped on the RAM. 128 byte, that RAM is there. So on which these all fellows are mapped, right? And these are the addresses available on the RAM. uh, on which this. So these numbers are actually software controlled, right? This is written in the ROM. Whenever it sees the RAM, it will make sure that this address on the RAM is going to work for the timer. Okay, so this is like a numbers which are managing the RAM, and RAM is behaving like a blank box, like a cupboard. You have got the cupboard, whether you want to put clothes, or you want to keep books, or you want to keep some ornaments, your stationery, or valuable things, that is decided by you. So same way, RAM has to store some number, some digits. What RAM is going to store is decided by the program written in the ROM. The sectioning is done, and then it is designated by the code, right? So this is the address on which. So it says that PC is not part of the special function register and has no internal RAM address. So program counter is the um, different thing. It has no internal RAM address. It is not available for the user, right? All these address can be controlled by the user, and it can see even the stack pointer manipulation is not normally allowed to user. It is taken care by the CPU only. Same way, the program counter information cannot be handled by the user. It is totally a CPU domain. Okay, for the safer side, anybody can think that if we can use program counter, how in a better manner we can use this. Uh, so that means in a sensible manner, because if you interrupt address in the program counter, what will happen? The funny thing is that it is executing, the processor is executing one program, and suddenly it will jump to some different address, and automatically it will show the hanging signal or error. This you must have seen many times. Uh, if you write some program in some location in 8085 and the batteries are not working, so it cannot store in its memory, and the moment you power off and again you power on, and you just remember that last time I have written this program at this C100, so let us run that program, and it will tell you that some random things are there, automatically generated. So this is there. Okay. So internal ROM is like it has some address. The role of internal ROM is that it has to hold the code which are necessary for the CPU for the operation. Many things are written here, but basic work of ROM is it is read-only memory. It has a codes associated with certain instruction like add, subtract, multiply, divide. Jump loop is there. So this subroutine call, everything is written in the form of an program, and these instructions are stored at different location in the ROM, and wherever whenever it is necessary, uh, then that instruction will call that subroutine, and then it will jump to loop the material present in that particular part of the ROM, right? And it will do the operation on the given data. So role of ROM uh, is like holding the operating system in it, like our mobile case. NAND RAM is there. So people do not tell that it is ROM, but it is a NAND RAM. But certain part of the RAM is acting like a ROM, which you cannot delete easily unless and until you have a proper software and the PC software. So where you can change the operating system, means you can just use firmware of your choice, like you want to use Samsung firmware into some different mobile phone. All of them are working on Android, but still within the Android, that operating system or the firmware are different, and these are the seller's choice. But some smart people can modify this. So in my Samsung mobile, I want to use Sony firmware, like this. So the way we do it in computer, you can use Linux or int microprocessor, that XP or Windows 7. Same things you can do it. You have to just understand what are the things and how the OS is working. Okay. So there are output pins, ports, and the circuit. So I will take just 5 to 10 minutes more, and then I will stop. So just now we have seen that the rest part of that output pins are there, ports are there, circuits are there. Let me check whether I have this diagram or microcontroller. Uh, Pin out diagram if I can have in this book will be better. Okay, no, this fellow is directly working with the program. So, anyways, this book has, or let me see if this tutorial is having that pinout diagram. Okay, uh, so if you see the pinout diagram, you will realize that yeah, anyways, these are the total 40 pins available, and you can see the port uh, 1 bit 0 to 7, these are 8 pins. Then there is a reset again. So you can just, just looking and understanding it, what are the role of this, you will come to know that these are the ports and they have a certain functions associated with it, right? So this port, we look at it as a different input or output thing, but also it is associated with certain things like INTO, INTR, write protect, read pin, write pin. There may be some port pin, certain pins of the port associated with interrupts, right? But we study interrupt as a separate entity, we study port as a separate entity. So first we have to understand the role of the port, and then how the pin are assigned to that particular port and the role of this. So these pins are actually associated with reading and writing the external memory. So it serves as address bus also. uh, Port 0 means port 0 and port 2 are bidirectional. Okay. So they are bidirectional because first the processor has to initiate the external memory address. So that is done by these ports, port 0 and 2, even numbers. And after that, it will send or receive the data. So when it is working as an address bus, it is unidirectional. When it is transferring data, it is bidirectional. Port 1 and 3, these odd ports, are associated with certain data inputs or certain controls. Okay. So each port is having 8 pins. 8 uh, So 32 pins out of 40 pins are, you can see that associated with only the business of certain controls by the port. After that, whatever pins are remaining, 8 pins, they are associated with power, clock, power and ground, there is a clock, and certain interrupt and the reset button, right? So this is the thing. This way one can remember the pinout diagram. That's why I wanted this diagram, that how to just see how this microcontroller is working, or the pin arrangement is done. Now in this pinout diagram, we have seen the pinout diagram. Uh, there are certain circuits which are employed, external circuit. Either you have a clock pulse generator using crystal oscillator, otherwise you have a that RC network circuit resistor capacitor, which can act like an oscillator, and then it can give you the stable multi vibrations, and which serves as a clock. So uh, this processor requires a clock pulse. It is only the shifting of 0 and 1 voltage level. So the moment you have all these 0 1 0 1 voltage level, automatically it will consider that as a clock, and it will start functioning. And then we have seen in the video also, the operating frequency is some 20 megahertz maximum. That too also 8051, some C or D, that high end 8051 microcontroller. So around 8 megahertz to 20 megahertz it can operate. The working frequency can be manipulated externally. Whatever the quartz oscillator you employ, that will decide the working frequency. But maximum 20 hertz it will work. So 20 into 10 raised to 6 operations, we can just say that it can perform. But actually, to perform one to execute one instruction, it may require certain clock pulse, right? Or multiple of clock pulse. So for say individual operation, one instruction, execution of one instruction may employ 8 clock pulse. So that is one machine cycle. So even though it is 20 megahertz frequency, 20 divided by the machine cycle will tell you the number of operations it can perform, maximum operation. So 80 megahertz divided by 8 clock pulse, or 8, that will be the value that you will obtain um, for that particular number of operations this microcontroller or microprocessor can perform. Um, So it has a certain description given. This pin flexibility it implies simply as a signal component with IO only, or this thing. So there is information which is written that what is the address and how we can do it. Now there is a one thing that is there, that it has a D type output latch for each pin. So each port has a D type output latch. So you must have studied the D flip flop in your BSc. So this flip flop is utilized as a latch for individual pin. So in this case, what is happening, that unless and until you enable this D latch, it is not going to send or receive the data. So what is happening, that it is acting like a buffer. CPU understand what kind of data it is going to receive, and then after that it will enable or disable the D latch. So if you are not enabling D latch, but still you can just try to store certain data at the input part of the D latch, or inner part of the D latch. And people, until the next clock pulse comes and the D latch is enabled, the data will not be transferred. So it is acting like a temporary register, where you can store some number, some 0 1. But to employ all this facility, you need to understand how to program the 8051, and then utilize for your better purpose. Now, port 0, we have seen it is bidirectional. Port 1 is sort of a unidirectional. So here the pin circuit is given for the understanding purpose, that how one pin is going to send and receive the data when the latch is enabled. You can try to just go through this image. uh, we are not interested to discuss functioning of this pin circuit, port pin. We have to understand that there is a port, there is a box which is having all this circuit. There is a one button called as enable. When you enable it, it is going to send or receive the signal. And also it requires the clock pulse, right? So this part we have studied. If you want to have a more understanding, then you can do it. and otherwise for our MSc part it is not required. Uh, Again, this port 1 is unidirectional. Port 2 is input output port because it is also associated with the address of the external memory location. Port 3 has got all these things. So I will just discuss and stop here. Port 3.0, 3.1, so pin number 0, 1, 2, 3 up to 7 for the port 3. It has a serial data input, serial data output. Okay. Then we have a external interrupt 0, right? So INT 0 and associated with the timer control 1. Okay. Then there is a interrupt 1, external interrupt 1. So timer control 3. Then we have a T0. So this is now you can see active low interrupt. These are active low. So normally they are 1. Whenever any interrupt comes, it goes to 0, and then this becomes activated, or this sense that now the signal is coming. So wherever you see the bar, these are active low. Now T0, T1, these are the timer 0 and timer 1 inputs. Then external memory write pulse and external memory read pulse. So whenever you are writing to the external memory, you have to first generate this active low pulse. That pulse will also enable port 2 and port 0, which are looking after the addresses. Okay, so they will select the address, right? And that address will be enabled by multiplexer and demultiplexer circuitry. Now once they choose the address, after that this external memory write pulse will go, right? Means now after this pulse, the data is going to come through again the port 0 and port 1, right? Because these are also database, data bus. So actually port 0 will send the data. uh, there is a 2 raised to 16, you can see, address accessible by with the help of port 0 and port 2. And then there is a 8-bit data bus. So the address bus is 16-bit for the external memory, and the data bus is 8-bit. So first you locate the memory where you want to memory address where you want to store the data. The postman does like, first he sees the pin code, right? Means he come to know the area where he has to go. After that he reads the name and the address, where what is the flat number, building number, all these things. So this is done by address bus. Then the WR initiate that, now write the date number. So automatically it will reach to the destination. Okay. Similarly for the reading, what will happen that the address bus will be enabled. It will locate the memory address. Then the read pulse will go, and then the data will be transferred through the port 0 to the CPU or the internal memory. Okay. So this is a small use we can see, and then there are many things that we will see later on, uh, maybe in next lecture. Okay, so I will stop here. I will stop recording.